Hello student, in this video I will discuss about the translation between representation section free response question. In free response question, there is a question which is related to the section translation between representation. Means you have a single scenario in this question. A block is compressed by some distance and it will release, then again reaches the mean position to extreme position and start SHM with fixed time period or angular velocity. But we have to represent in different by different method, like in a graph, like a bar chart, in a sinusoidal graph. Let's see. So in this question, the question is explaining the motion of the object and the kinetic energy and potential energy of the object in this complete page. So they want to ask, if you want to ask to draw the similar bar chart uh, at x equal to 0 or at x equal to plus x naught. So understand firstly the motion of the particle, because you compress external agent compress the string, then total potential energy become half k x naught square, because x naught is a compression and it is extreme position, so speed is 0. So then kinetic energy will also 0 when it release and again reaches to the mean position. Then compression becomes 0, then kinetic energy will become maximum and potential energy will become 0 because there is no compression in the spring. Now it further move to the extreme position and again compression become maximum, so potential energy become maximum and kinetic energy become 0. That is a simple understanding. So this is a complete simple harmonic motion from extreme to mean, mean to extreme, then extreme to mean, and mean to extreme. So now we can draw the bar chart. So that is a translation. How you translate one information into other kind of information. That's why it is called translation. So at the mean position, kinetic energy will be maximum because total energy is constant, kinetic plus potential. So there is a you need to be conscious about the unit or scaling. So there is a 3 block. So you have to write complete 3 block, because complete kinetic energy potential energy is converted into kinetic energy. Then again extreme position, the kinetic energy will become 0. So this is the answer of this graph. Now we move further. Now it is given the position time graph and force time graph. Obviously you can also draw the position time graph, because it is mentioned that at t equal to 0, it is mentioned in the question that at t equal to 0 it starts from minus x naught. So I can easily predict the relationship, because it is a SHM, simple harmonic motion, so we need sinusoidal equation. So I can easily predict that the function is of cos omega t. Why? Because at t equal to 0, the magnitude should be minus x naught. So when I put the value of t, cos 0 become 1, then displacement is minus x naught. And the in SHM we can write f equal to minus kx, and when the putting the function of position by minus x naught omega t, so we will have the function of force kx naught cos omega t. So f is also the cos function and the x is the also function of cos. So easily we can draw the graph. So that is a graph of cos function for both position and force. So at t equal to 0, we can read AP exam all about graph, literally. So at t equal to 0, the force is maximum and the displacement, or you can say amplitude, is minus x naught. So now what they want to ask, they want to ask to determine the expression for the spring constant. Spring constant is constant, but the force and position not constant, it continuously changing. But we know at t equal to 0, the value of force is F max. It is given in that graph. And at t equal to 0, amplitude is x naught. I am only writing amplitude because I need value of constant. So I do not need to write the sign minus x naught. So K comes out F max upon x naught. So this is the answer of this part. Now move further. Now they say the time period of the particle and also express the mass of the particle in term of T naught, x naught and F. So it is also the easy work because we know that the time period can written by 2 pi root m by k. So first we have to understand what is the time period in this graph. By seeing this in this graph, uh, we can we know the wavelength distance between the complete wave is called between two crust and crust, consecutive crust. So that is a crust and crust. So that is a complete wave. And to travel a wavelength lambda, it take total time period t. So time period is 2t naught. So now we got that the total time period in this graph is 2t naught. In the terms of t naught, that is 2t naught. So t naught can also be represented t by 2. Means half t naught is a half time period or two t naught is a complete time period. For example, block starts from minus x naught, then it reaches to x equal to 0, then it reaches to x naught plus. So this complete time interval is t naught and this complete time interval is t naught. So total time of oscillation is 2t naught. That is my point. Okay, get it? Now further we understand that t is twice of t naught and 2 pi root m by k. Now this relationship we can find the relationship of mass by squaring both sides. We will get m equal to t naught square k upon pi square. So that is a relationship of mass between these parameters. So that is the answer. Now they want to sketch the velocity time graph. That is a very simple question because we know the position time graph, and by differentiate the position time graph we easily find the velocity time graph. So by differentiate it you can easily the position time graph depends on cos function. So we need to write cos position minus cos omega t. By differentiate cos omega t will give minus sign, minus minus become positive, to x omega sine omega t will be the function of velocity. The velocity depend on sine function, so it easily we can draw the x omega is a maximum amplitude. So v max we can put the maximum value is x naught omega. Okay, x naught is a amplitude. Now we can draw because we know that at t naught is a, I have earlier told you that t naught is a time from extreme to extreme, and again t naught is a time for extreme to extreme. So t naught and 2 t naught particle will be in the rest, and for t equal to 0.5 t naught and t equal to 1.5 t naught particle at mean position, so the velocity will be maximum. So you can draw it very simply like that. So this is a velocity time graph. So at 0.5 t naught and 1.5 t naught, the velocity is maximum, means at mean position force is 0. So velocity is maximum at this position. So now further we move. Now last D section, it is asked that the student draw a free body diagram at t equal to 1.5 t naught, and a student is claiming that uh, claiming that there is some net force at 1.5 t naught, because we know that at t equal to 1.5 t naught is the force is 0. You can see the graph of force at t equal to 1.5 t naught is a force is 0. So how can we draw the net force on the object? So it is a wrong claiming. So you can write that at t equal to 1.5 t naught force is 0. So there will be no horizontal net force and the velocity is maximum at that point. So this is a complete answer of the question related to translation between representation. So first question, there total 12 point, and in 12 point part A consists of 3 point. You have to explain these 3 points. Now relationship between K, T, M, we have discussed this relationship already. Now velocity time graph, we have discussed the velocity time graph, and uh, the claim three body diagram are not consistent because at t equal to 1.5 knot the net force on the spring is 0. So this is a simple solution related to the this segment. Thank you.